Hi viewers, welcome to today's episode of our lesson. In today's episode, we are continuing with our problem solving under empirical formulas and molecular formulas. In the question we have here today, we have that we should determine the empirical formula of an oxide of nitrogen containing 70% of oxygen if the relative molecular mass of the oxide is 92. Then we should also deduce its molecular formula. So if you look at this question critically, we are required to calculate for the empirical formula and also to solve for the molecular formula. And in the question we have been showed that it is an oxide of nitrogen, saying that, which means that it contains only nitrogen and oxygen. We have already established that this particular compound contains nitrogen and oxygen, as it is an oxide of nitrogen. So the element involved is nitrogen and oxygen. And we are told that it contains 70% of oxygen. Percentage composition of oxygen is equal to 70%. But we are not told the percentage composition of nitrogen. But since we know that this compound only contains oxygen and nitrogen, and oxygen already is 70%, then it means that the remaining portion of the compound will be nitrogen. So, and you can only get 100%. So 100% minus 70% will give us 30%. So the percentage composition of nitrogen will now be 30%. So since we have this and we have this, the next thing to do is to divide each one by the relative atomic mass of the elements. So the relative atomic mass for nitrogen is 14 and the relative atomic mass for oxygen is 16. So we divide this by 14 and we divide these two by 16. So 30 divided by 14 will give us 2.142. To give us 2.142, and 70 divided by 16 will give us 4.375. Will give us 4.375. So since we have this already, then we go ahead to divide with the one that have the smaller number, and 2.142 have the smaller number here. So we divide through with 2.142. So 2.142 divided by 2.142, of course, will give us 1. Then 4.375 divided by 2.142. This will give us 2. So the ratio of the nitrogen to the oxygen will be equal to 1:2. So since we have this, so we now know that the empirical formula, therefore, will now be equal to NO2. That is 1 nitrogen to 2 oxygen. This is the empirical formula. Now that we have the empirical formula and we are given the molecular mass, to be 90, then we need to now solve for the molecular formula using the information we have. So if we are to do that, then we will now have that the molecular formula will now be equal to NO2 in bracket X to be equal to 92. Okay, so we are solving for x. N, the mass of N is 14, and the mass of oxygen is 16. And here we have 2 oxygen. So 2 times 16, which is 32. So here we have NO2. Now the relative atomic mass of nitrogen is 14, and the relative atomic mass of oxygen is 16. And here we have 2 oxygen, which is 32. Okay, so 32 plus 14 will give us 46. So we now have that 46x is equal to 92. Okay, which implies that x is equal to 92 all over 46. Okay, if 46 divide 92, we have 2. Okay, so x will now be equal to 2. So if x is equal to 2, then the molecular formula will now be 2 times NO2. And if we do that, we now have N2O4. So the molecular formula is of the nitrogen oxide is N2O4. So this is our answer. Thank you for joining us in today's episode of our lesson. If you are new to our channel, please subscribe and give this video a thumbs up. And if you have any confusion or a question you want us to attend to together, please drop it on the comment section and we attend to you. Thank you for watching. See you in our next class.